Hello YouTube, this is your host Poison and welcome back to the another video of Cyber Deconstructed. What if I told you that one simple input can manipulate an entire database? No malware, no stolen password, just a craftful query entered into an ordinary website form. This attack is called SQL Injection and it can allow an attacker to bypass authentication, expose sensitive information, modify records, or even delete an entire database. So before starting the video, I'm going to tell you that we are doing an episode format of every cyber attacks explanation. This is purely based on theory. If you're not understanding it, please comment down below. Welcome to the episode 1 of Cyber Attacks Deconstructed. In this episode, we will break down how SQL injection actually works, why vulnerable applications execute malicious input, and how developers and security professionals can prevent it. Everything shown here is for educational purpose and authorized lab environments only. Now let's deconstruct SQL injection. What is a SQL injection? SQL injection happens when user controlled input is interpreted as part of a SQL query instead of being treated only as a data. The fundamental problem? Data becomes code. Yes, SQL injection. SQL is such a query which can help you to manipulate the database by simply inputting a malicious query, and that database provides you with the user information as an query rather than as an data. In color convention, blue, legitimate application logic should be applicable, and for red, attacker control input. For blue team, they should have a legitimate application logic for their applications, and for attacker, that is red team, attacker should have a controlled input. How a normal request works: user enters Alice, app constructs query, SQL send to database, and result return. When a user search for Alice, that Alice that search constructs a query, which query is then sent to the database, and then database fetch the data required to that query and send back to the user. The application take user input, construct a database query, send it to the database, and return the result. Input stays as data, nothing more, nothing less. Where the vulnerability begins. Here is a simple query of SQL injection. Query: select everything, that is asterisk everything from table users where the username is Alice. Here it should be Alice. But if an attacker would try to do it, he will do it. Select everything from users where username is blank and an extra apostrophe to end a query and attach a new one. It also generates a user input where query takes the user input and then ends it with a semicolon. So here attacker is basically trying to append the user input form or user input, as we can say, user input access to the query. Data plus SQL code are being mixed. As you can see, this is SQL code till here, and this is query. Yep. The application directly combines attacker control input with SQL syntax. Blue team developer SQL. The fixed SQL code the developer write. Red team user input. Raw unvalidated attacker control strings. User only, the developer only sees, yes, yeah, only this query will run, then the user will get the data, but not the attacker. Attacker will always think, yes, this is the query, what I can append it to get more data than I have to see. Yeah, Deconstructing the attack. Normal input Alice. Normal query, select everything from user where username is Alice. This is what a normal user inputs. But what the attacker does, he will just input instead of name, single apostrophe or 1 is equal to 1 and double dash. What it does, as we know, let's go here, let's do it here. Yeah. So what normal, wait a second, put this, is its size. Yeah. Yeah. So what normal users search is only Alice, and how database see it, select select everything from users where username is equal to Alice. This is what a query goes from a normal user. But what will attacker do? Attacker user search. Instead of putting Alice, he will just put single apostrophe or single apostrophe 1 apostrophe, which is equal to what. So what is does? As query goes like this apostrophe will append here, and it will does or dash one. Sorry, single apostrophe 1, which is equal to single apostrophe 1. So what is check? Is the name true, or is the name false, or 1 is equal to 1? Check. It will basically, so how database sees it? Database sees it like, wait a second, let me remove this from here. Let me select this one. Okay. Let me paste it here. Yeah. So what database sees? It sees select everything from username where username is blank, the single apostrophe that is appended, or yeah. So what database sees? It sees select everything from users where username is empty. So there in database the username should not be empty. So here it goes false, and then it for goes operator, that is operator not, it says, as you can say, mm, checkings bitwise operator. Yeah. Yeah. So what it is does, username should be empty, no, false, or 1 is equal to 1, and remember these both are string, so yes. So what it does, according to truth table, false or true. So according to truth table, false and truth when are used in or bitwise operator, it will gives us true, and database grants the access to the user to the database. Always true. The condition 11 makes the where clause evaluate to true for every row. Authentication is bypass completed. So, yeah. Why does SQL injection works? Combine SQL plus input, construct final SQL, parser receives statement, database executes it. Why it is work? There is simple. When an attacker manipulates user input section with a SQL query, it finally forms a SQL query, which is then received to the database, which is received to the website, and from that website goes to the database, and database executes it. The core problem. The database parser cannot distinguish between developer written SQL and attacker injected SQL. As database just has, sorry to use this word, but database is just dumb. It doesn't understand what a user types and what is SQL query. It can't differentiate it. So when an attacker types an SQL query as an user input, the database thinks, oh, this is an SQL query. I should use it, execute it, and give the answer to the user. Yeah, that's dumb database, that is SQL. So SQL executes it and give the database all access to the user or all information to the user. The database is SQL syntax, not the attacker's intention. No context boundary. Input and code arrives as one string. Yeah, parser trusts the string, executes whatever valid SQL injection. So there are two basic problems, that is user input and code arrived as a string. Okay, and parser trusts that string, executes whatever valid SQL is received from the user or the attacker, and executes it on the database. So now let's understand complete SQL injection attack flow. First, attack chain. Craft malicious input. Then that input is sent to the HTTP request. That HTTP request is carries that payload, reaches the app with the vulnerable parameter which can't understand the difference between code and input user string. That parameter is then goes to unsafe query construction. That parameter helps to generate unsafe query construction. In short, it will generate a query, not see it as a user input. Then that unsafe query is goes to the database. Database executes modified query. Database executes the user's input query, and an unexpected response reveal vulnerability. Common injection points are URL. These are the injection points where you can try to fetch or do SQL injection. That is URL parameter, search fields, login forms, filters, API parameters. As we understood what SQL injection is, how the attacker tries to manipulate it, now we see what a defender, the person who is trying to deal or defend from all this SQL injection thing, what he sees. Monitoring source, web server logs, HTTP request and response. The defender will see HTTP request and response on his web server logs. On his application log, the query construction and error. Defender sees on his application log the query, how it is constructed, and why it didn't show an error. While checking database log, he will check or he will see an executed query and access pattern. And what is WAF alerts? Suspicious parameter patterns. These are the defenders. These are the points that a defender should notice and see. Next is potential indicators. SQL syntax is an unexpected parameter. These are the indicators which a blue teamer or a defender should look for. SQL syntax in unexpected parameter. Repeatedly malformed request. While checking web server logs, he should also check repeated malformed request. Database error response. While checking database logs, he should also check database error responses. My bad, sorry. Let me check. Yeah, we are recording. Sorry. And also, while checking the database log or WAF alerts, he should also see the actual size of the parameter which is sent. And also, he should look for such suspicious operators like OR, Okay, sorry, I forgot to explain you this. These two lines. What these two lines is used in SQL. These two lines basically means comment out comment out the REST query, which will tell database, oh, hello, take this query and just use this, execute it, and give me answer slash info. So this is the comment query. This is semicolon, that is end of the query, and this is union, which is used to append everything. These are the evidence that an attacker leaves, and that should be checked by defender in every web server application logs, web server logs, application log, database logs, and WAF alert. So here in this diagram there are four sections. First is vulnerable user input. The attacker enters malicious SQL into a form such as previous this one. Next, vulnerable string concatenation. The application directly joins that input with an SQL query. That is, select everything from users where username is blank, pause plus user input plus, yeah. This is unsafe transformation. The input is treated as SQL code instead of normal data. Third is vulnerable SQL statement, that is DB. The final query may become everything as we seen before, and the final query becomes this. So this becomes true, and the query could not and the query could return every user. Fourth is secure parameterized query. The application keeps the SQL instructions and user data separate. Now the database treat everything here as an ordinary username, not a SQL injection. In one sentence, SQL injection happens when user input is directly mixed into an SQL query. Parameterized query prevent it by treating the input only as data. Yep. Here are the points. Okay. No. Here are the points that are, I guess, every depth in a defense in depth control should be carried out. First is parameterized queries. Primary defense, separate code from data. Least privileged database account, limit what a compromised query can do. Input validation, secondary layer, not a replacement. Always use a secondary layer. WAF plus logging plus code review. Every defender should detect, monitor, and verify the code. Input validation is not a replacement for parameterized query. Always use parameterized query as the primary control. So in this module, in this episode, what we learned, we are going to see that attack, user controlled input influence SQL syntax. User inputs a controlled SQL syntax parameter. Why it works? App mixes untrusted data with SQL instruction. Detection, web app WAF, web app WAF, and database logs reveal suspicious behavior. Defense, parameterized queries keep SQL and data separate. Four key takeaways. SQL injection begins with an untrusted input. Second, unsafe query constructions let input influence SQL injection. Third, the database executes the resulting query. Fourth, parameterized queries are the primary defense. Before ending that, we will head to our diagram and see how an actual normal request look like and how an SQL injection request look like. Wait a second, we increase it. Nice. So in SQL injection, when a normal user input Alice, the web application builds the query like say SQL query. Select everything from user where username is Alice. Then that query is sent to the database and that normal results only shows Alice's row to the user. But in SQL injection, attacker types this query. Vulnerable app concatenates input straight into SQL. Without treating it as a string, the vulnerable web application uses it as a query and forms a query that is select everything from users where username is empty, which is false, or 1 is equal to 1, which is true, and rest it comment out. As 1 is equal to 1 is always true, it is goes to the database and database gives the unauthorized results to the actor. The root cause of it, unsafe string concatenation mixes untrusted data with SQL code. So input can rewrite query structure. Prevention, parameterized query, prepared statement. Every code should be treated as a code and every input string is treated as to be input string. Okay, as we seen here. Yeah, as we seen here, there should be one layer where if an attacker tries to input a malicious query, he should be only given access to the particular things to view or see or access. And what a second layer should do, it should always check the input that the attacker provides. So these are the parameters that we should follow, and always write code and data stay separate, input treated only as a value. Key ideas: SQL injection happens when untrusted input changes SQL query structure. Parameterized query keep data and separate code separate. So that's for it, folks. This is the episode 1 of SQL injection cyber attack deconstructed. So remember, we are going to follow a series of episode of every attack deconstruct. Okay, so keep follow up. Do subscribe to the channel. Hit the bell icon so you will be get notified what is the next attack that we are going to deconstruct. Till then, take care. Thank you. Bye bye.